Meet The Lot, native token of Lukki Exchange and the most potential tool for investing this year. Trade now on P2B, B2B and Lukki.io.
About cloud computing, I mean, let's keep it interactive. If I'm too boring, stop me, ask me questions anytime. A quick intro about myself first and the rest of the team. I'm the founding partner and CEO at Eterna Capital, which is an investment fund investing in blockchain projects at the very early stage. We invest in both token and equities. You can find all our investments on our website, eternacapital.com. Before Eterna Capital, I used to run my own company, and my 3 colleagues used to work for BlackRock in London. I think for us, the point is always how do we add value when we basically take investment decisions. And one important element is for sure research, ensuring that we really know what we're talking about. We research on the verticals we think are more relevant, and the cloud computing is one of them. We think there is a lot of room for blockchain to disrupt cloud computing. And the presentation I'm gonna show you today is basically a subset of a research paper from our head of research, Mattia. If you're interested in the full research paper, you can just Google Eterna Capital Cloud Computing. You will find a quite long Medium post, and there you can find all the details about it. But let's start now with the presentation. So the way I broke it up is as follows. So the first part is just about giving you a snapshot of the current market on cloud computing. In the future, how is it going to look in the face of more data being produced globally? And then saying, okay, can we actually use a decentralized approach to cloud computing? And then explore a few solutions on the blockchain space. Before I start, does anyone know what cloud computing is? Does anyone want to give a definition, like an example? Like, what is an example of a cloud computing application? Is anyone brave enough to provide an example? Sorry? Mining. But like for me, like the most easy example is, for instance, Gmail, right? You're not hosting the Gmail on your own server. If you go to Gmail, you then also have many other services you can use. You have G drives, which is basically Excel on the cloud. And yeah, the idea is that you don't host the operations on your own server, on your own laptop, but is in the cloud. And if you see how the cloud computing market looks like at the moment, is dominated by a few key players, being Amazon, Microsoft, and Google mostly. Amazon with Amazon Web Services has around 33% of the market, and is a sector that is really growing very fast. By 2021, is expected to have 300 billion in global revenue per year. And in 2017, we were in a situation where we had 17 billion per quarter. So it's growing exponentially, but as I said, is dominated by large corporations. Then what's happening? These corporations, they see that, oh, it's so popular, and there are so many things you can do with cloud computing. So what's happening is they are making existing products relatively complex. They are deploying many new features. Amazon Web Services and Microsoft, they're releasing 40 to 50 new cloud features every month. But what actually organizations do in the end, they only use a handful of those features. So by 2020 is a sector which is expecting to triple, even in terms of number of providers, but existing solutions are getting quite complex. Now, there is a research from Gartner that points out what are the main risks of cloud computing. And first of all, cloud computing is emerging as one of the main risks for corporates. And the main concerns are around security, because if you have information and the computing power on the cloud, then you will need to grant access to a third party to access that. So there might be security breaches. Then, as I mentioned before, the infrastructure complexity is increasing, and that's not something which is helpful. And as well, cloud providers, they should be careful about things like downtime. Like if the server goes down, then you cannot access whatever you want to access. This is a problem. Concerns, since cloud providers sometimes may fail to meet the GDPR legal needs. And then, as well, as I mentioned, like the risk of data loss in case these servers are hacked. And then, as well, one problem is if you have, in the end, a central organization like Amazon, Google, or Microsoft running the servers, you are at risk of that organization modifying your data or changing something. And it's nice now to bring a more like a blockchain slash crypto anecdote. I was reading an interview of Vitalik Buterin, the founder of and the creator of Ethereum, that was saying one of the motivations to start thinking about decentralized applications was that he was playing World of Warcraft. He was a big fan of World of Warcraft, and one of his main characters had his features altered by the company that was basically providing the game. So it was like, why? Like they basically decided arbitrarily to do that, but in a context where this is on a decentralized governance, that will not be possible. So that's something to bear in mind as well when we have this kind of central organization managing such important tasks. Then, second part is about the future, how the future is going to look from a data standpoint. What we see is that we're going to have an avalanche of data produced in the future, more and more. Just to give you an interesting piece of information, 90% of all the data produced by humanity since the Big Bang until now has been produced over the last 2 years. So this shows you the rate at which data is growing. And now with the Internet of Things, things like self-driving cars will have exponential growth of data production. Just think that for self-driving cars, a self-driving car can produce up to 1 gigabyte of data per second. So in this context of having an enormous amount of data available, you need to find smart ways to deal with such data. The thing is, the main question is, in this context, how can a centralized cloud infrastructure support that level of computing power needed? And at the same time, ensure that it's still scalable and there are, let's say, the risks of hacking and compromising the data is minimized. Then what you can think about is to say, okay, we move from having everything on our own servers and laptops in the clouds. Now let's try to maybe think about a decentralized approach towards operating data in the clouds. So devices that are closer to the end user. For instance, to give an example, routers. So the idea is that you don't do the entire computation in one massive cloud, but you delegate some tasks to these edge devices. And this makes everything more secure and makes everything even more scalable. Now, here to just give the level of how the opportunity for edge computing is, just look at this graph. So it's showing the usable data created per year versus the data center traffic. So on the bottom line, you have the data center traffic. The data are in tens of zettabytes. 1 zettabyte is 1 trillion gigabytes. And you see that there is a massive gap between the usable data created per year and the data managed by data center, meaning that there is a lot of data usable. Like in 2021, you have 85 there, but the traffic is forecasted to be only 21. So there is a big gap that is not addressed unless you actually do the right steps from a technological standpoint. And then the reality is that having sharing computing power is not something new. It's something that in the past has been used already. Here is an example of SETI Home. That was a scientific experiment at the University of Berkeley. They were trying to interconnect computers to search for extraterrestrial activities. Here, the problem is you had the technologies back then to do it, but the concerns were it's still something that is centralized, and this has security pitfalls, of course. And the main point is there was a lack of incentivization plans. It was like a peer-to-peer situation, like BitTorrent, let's say. It worked fine, but you did not have strong incentives for actors to provide value to the network. And then the problem was also about the lack of verifiability of the correct performed computation. So there was no check at that point. So the idea is, okay, that's something that was used. Can we now go one step further and see how blockchain can help bring this technology to the next level? Yeah, I think we can, and there are several examples that are trying to do that. One of the main, let's say, the main benefits of blockchain, of plugging blockchain into it, is that first of all, you allow a true decentralized system that will make everything more secure. Because of course, if you want to hack that, you don't know where to start from. You don't know where these servers are located. And as well, from an incentivization standpoint, you do have tokens, native cryptocurrencies that they serve to incentivize the various players in the network. So again, to summarize, like, what are the main challenges of the cloud solutions, even if you want to use blockchain? So first of all, it's fine. We can have incentivizations in place, but we need to ensure that the incentives are structured in a proper way, right? There are many ways, you can be very creative from the point of view of which consensus you want to use, but you need to ensure that it's the right one for the kind of application that you want to deploy. And then one key part is to make it scalable. We have seen many blockchain solutions being very interesting, but the main bottleneck of the technology is to ensure that they are scalable, secure, and decentralized. So the so-called blockchain trilemma is actually solved. And then as well, if you want to verify the computation, you need to ensure that this is done in a proper manner to ensure that malicious attacks are avoided. And then as well, another element is about these so-called oracles. So if you have a system that connects a blockchain to the real world, whoever inputs the information in the blockchain should be someone trusted, because that's something that is difficult to decentralize. And again, you need also to manage the risk. So, I mean, this is like, in some cases you can have that in case there are attacks, and some blockchain might also have the capabilities to revert some of the past transactions. You need to ensure whether this is appropriate based on what you are doing. Now here we are going into a few applications that are quite interesting in my opinion. As a disclaimer, we did invest as Eterna Capital in one of them, Dfinity, but I'll go fast on them because they're actually quite complex if you go into all the details. So if you have any questions, feel free to ask me as well later on, or feel free to go and read the entire white paper. But I'll try to basically tell you the peculiarities, what they have different one from another, but in the end, they all try to solve the same problem. So bringing cloud computing on the blockchain and decentralizing it. So the first is Ankh network. The approach they have towards cloud computing is to say, okay, fine, you have an edge device, cool. You can all connect and you can share together the unused capacity. So you can sort of create like a marketplace, like a sharing economy marketplace for excess of computing power. And they then said, okay, one very complex thing to do in cloud computing if you use blockchain is to create a so-called virtual machine. So some projects, what they say is, okay, let's bring the entire cloud computing, digitize like one part of the process to ensure that we have like different clusters, and those are links to the edge devices, and we don't we just deal with each of them in a separate way. It's like a divide and conquer approach. They've also designed a consensus mechanism called trusted proof of work. Useful proof of work, which is, let's say, an improvement compared to the consensus mechanism used by Bitcoin, the so-called proof of work. And they're currently developing their solution. So we'll see if they'll manage to succeed. The other project is quite interesting is Dfinity. As I mentioned, as a disclaimer, we have invested them. Other funds as well have invested, such as Polychain Capital, A16Z, which is the crypto branch of Anderson Horowitz, is actually one of their main investments. And what Dfinity tries to do is to say, okay, let's actually try to do things the difficult way. Let's create this virtual machine, this supercomputer, and then let's try to everyone to connect in this supercomputer that is basically running all the applications, all the software that exists. So it's a very ambitious project. Again, they're still currently developing it. You might have heard that these autonomous organizations sometimes, are governed by smart contracts, and we hear code is law, right? They're governed by code. For Dfinity, the rule is AI is law, so it's governed by AI. It's a very complex infrastructure where there is an AI that is governing everything. Transactions themselves sometimes can be retrieved if the AI thinks that they should be. You guys can check out all the details. And then another one that I wanted to analyze as well is Solana. Solana is quite interesting because they have defined a new consensus mechanism called proof of history. Through this consensus mechanism, they basically managed to have the definition of time embedded into cloud computing, like the amount of data that's been processed. A parallel that you can use to understand that is a water clock. So it's like to calculate time, like how many seconds have passed, you have water pouring into a clock, and then you're like, okay, when it goes at level 1, I know that 1 minute has passed, and it goes to level 2, 2 minutes have passed, and so on. So the idea is that, think about now, the water is the data processed by a certain provider. So they basically are able to see the amount of data that is produced, when it's produced, and the entire consensus is around that. And by using this new consensus mechanism, they managed to create a blockchain platform that is very scalable. And we'll see what this approach will add. So these are all projects that are quite new. They are now in development. It's interesting to see which one will succeed, to what extent they will succeed. But the key, and it's just going to increase over the next few years, we need to find an effective way to manage and process the data. And centralized servers have their own limitations. You need to have a decentralized approach. And blockchain is pretty much solving the issue of giving the right incentives to people to participate. Because for sure, like, you can have just peer-to-peer platforms and people that are just voluntarily participating into that because it's good, because like it's a good cause. But in the end, if you also create the right incentives, you can ensure that everyone has the skin in the game and a reason to join and to participate into the network. So we're very excited to see how this will unfold over the next few years. I think these technologies are still at the very early stage, but they're very promising. And as an investment fund, what we do, we tend to basically see the different clusters we consider interesting, and then take a deep dive into it, and then look at the interesting projects there. So that's pretty much it about my overview on cloud computing. Here are my details. If you guys want to email me any questions on this presentation, or you have interesting blockchain projects you want to share with me, feel free to do that. You can follow me as well on Twitter. On the right